So, welcome. Can you hear me? Lecture number 12 in a series of 13. Next time, only summary and overview. So today is the last time with new stuff. And a little bit of different story today, but before we go to the different story, I have a different announcement or story. Just yesterday, as you can see, I sat in this room right here and heard a really nice lecture by a global big guy called Professor Soubin Ghahramani. He was talking to everyone at DTU about probabilistic machine learning. Machine learning is taking over the world, right? All over the place. He's going to be the chief scientist at the Uber company now, working with how to run self-driving cars by the use of machine learning. And there's nothing that we meet today where there is no some kind of machine learning. The thing is, that's the brand new name used, or it has been around for quite some years. The brand new hot name is deep learning. The name of the algorithms these years, these months that are sort of the hit, that's deep learning algorithms, deep learning methods. His message to the whole DTU and to the world is machine learning basically is statistical methods combined with optimization, so the mathematical concept of optimization, and then hardcore computer power, right? And disk place for big data. And his message also is the only way we can control these otherwise pretty uncontrollable machine learning tools is by means of probabilistic thinking and basic statistical reasoning. Because there is no way we can be on top of when they work and when they don't work and relate to the risks of using those tools if we don't have the basic statistical reasoning and probabilistic methods in place. As machine learning tools to a large extent is being developed in computer science areas, it's not given by the circumstances that the proper level of probabilistic thinking and statistical reasoning is going with all those tools in all contexts. But his message to us is those people who can deal with both are going to have a competitive advantage for the future. So here you are, guys. I introduced in this course some of the basics of statistical reasoning and the basics of statistical tools and sampling and errors, thinking about that. Now in later your life, you will meet a lot of machine learning approaches. If you didn't meet it already, maybe you'll take classes. By all means, take some classes in machine learning. That's a good idea. By some of my colleagues in the brilliant department that I'm part of. But don't forget statistics, right? Because if you want to be on top of why they work and why they maybe don't work sometimes, the tools I've been giving you on this course, I have introduced to you in this course because we have 30, 40 courses on statistics at this university on top of all our machine learning classes and you name it. So it's just the beginning. It's called Introductory to Statistics, what we're doing. It was a brilliant talk, so go and check him out. Anyone in here who was there? Why not? Didn't see it? Follow the news, please. Well, I don't always get all the news myself. Anyway, it's a good idea to follow the news. What are we up to today? Today we are up to something. There are a few Danish words, but I'll explain to you what it's about. I'm looking at some report from our health authority called Sundhedsstyrelsen. It's an old report, but nevertheless, these reports don't come out every year. Part of this report is telling us about the proportion of newborns in Denmark being born with some sort of malformations, right? Not good things. And that proportion is around between 4 and 5%, and here's the development from 94 up to 205. So each year we have the proportion of newborns in Denmark that was born with some kind of malformation, right? From severe ones to not severe ones. That's a grouping of everything. So when you coming moms and dads, I'm sorry to reveal that to you, but there is a 1 out of 20 risk, right? If you are that lucky that you pass the first risk of actually not being able to get at the point where you can give birth to a wonderful little baby, that's the risks of life that we deal with, right? Percentage, yeah, it seems to be increasing. But is it really increasing, or is it due to statistical noise? Because, yeah, what's actually going on? We have around, I don't know how many, 30, 40,000, I forgot the number, births in Denmark each year. And then there's a 50-50 chance each time of being malformated or not. If that's what I'm looking at, I don't care about the sex or the gender now. I'm caring about whether we're 100% okay or not 100% okay. So that's a binomial framework, right? Basically, we are throwing the coin 35,000 times each year, and then we count how many are okay and how many in this case are not okay. 5% roughly is not okay. Then we put, and Sundhedsstyrelsen, the health authorities, they use the tool that I'm going to teach you in 5 minutes from now. They use what is known as the confidence interval for such a proportion. Now disappeared. Here was the Danish. You can, even though you're not Danish speaking, I'm sure you can recognize confidence interval in these wordings here. So they use a 95% confidence interval for those proportions to give a bit of extra intelligence about looking at such proportions, which makes good sense. So it's just to tell you, people of course use those confidence intervals as they should. This is nice. There's nothing wrong in this. I'm just going to share this with you as one example of one of those reports that are being used, and confidence intervals are being used a lot to report numbers. Actually, in my book, it would be brilliant if all the p-values and hypothesis tests were removed and a lot of confidence intervals were put in the reports instead. I would be happy. But then again, we live with the confidence, with the p-value still. It's around, and if you can deal with it, it's okay. The problem is not everyone in the world can deal with it. But then again, it's in a one-to-one correspondence with the confidence interval. So, hey, if you know what is what, there's no problem in doing a p-value and hypothesis test. Where are we? We are going to do inference for proportions, right? Counting how many out of n successes or failures we are having. That's the purpose of today. And in that way, we are slightly different. I'll get the, here's the overview, sorry. We'll do the usual. We'll have the usual split in the middle, roughly here. Exactly there. And talking about, yeah, I think I have the overview here. That's why. Just looking back to what we did a few weeks ago, or during the course, we looked at statistics, and for us, statistical inference is hypothesis testing and confidence intervals. Maybe a little bit of prediction. We talked about prediction and regression. Prediction is very important for machine learners, but prediction in many ways is something you can sort of extract from your modeling and your estimates in any way. But the main purposes of this basic introduction to statistics is talking about hypothesis testing and confidence intervals and the risks and the uncertainties. We can do that for a single mean. That's where we started our statistical career a few weeks back, right? Back in fourth lecture or so, when we had a bit of probability, we did one sample stuff. Then we did two sample stuff, and then we did k-sample stuff in a couple of different versions. Now we'll do it all in one lecture, and even more. Now you're getting trained, so we can set up the speed. We're going to look at one proportion. Already we saw from the health authority report that was an example of many proportions. We'll start out by looking at one proportion at a time, and then we'll extend it such that we can look at two, we can compare two, we can look at many of those and compare them. And then we're going to make one final extension in terms of what situations we are going to deal with today, is that I call it multi-categorical proportions. Well, a proportion, when we say a proportion, is because in our mind it's a binary outcome, right? Either okay or not okay if it's a baby. Either gender, either male or female. Either Macron or Le Pen. We'll get back to that. There are only two options, right? But there could be several options. In what we just had in the French election, there were several options, right? Le Pen, Macron, and whatever they named, all the other ones, we already forgot those because they're not important anymore. There were a number of outcomes if you did the study by then. So it could be not only two categories, it could be multiple categories. We're going to do statistics for such categorical data, proportions data, count data, contingency table data, frequency table data. There are many sort of synonyms for what we will discuss today. Here is the basic thing, just to make sure that we're all on top of what a proportion is. The estimate of a single proportion is pretty easy, and this is a computation that I'm sure anyone would think like that. I ask 1,000 people, 600 of those 1,000 people in a poll said that they were gonna vote for Macron, right? And so I would compute the proportion in this poll to be 60% or 0.6. So now we do statistics for that proportion. The question is, what do we know about the real proportion of people in the population that prefers Macron? I do say it the right way. It's Macron, right? Good. I was just, I'm going to repeat this 50 times in my lecture. I should get it right right away. Good. Because, let's start the gaming. Oh, yeah. I'm not ever going to reveal my nickname from when I was a kid. It's not on the list. I'm sure you won't be able to find that on Google. Are we ready? I think we are. Use your gut feeling now. You don't know, but use your gut feeling. I'm gonna teach you in a sec, but I would like to see what your guess would be. This is as close to a uniform distribution on 4 categories we can come. Well, this is brilliant, because I could have used that in a scientific learning paper. I could have improved and statistically shown that you hopefully will be able to learn, because this is clearly no knowledge outcome here. So let's see who was fast and lucky. Fast and lucky. Maybe smart, we don't know. Because that's the first topic.